Hello there. This is a video on arithmetic sequences and series. I know that it's pronounced differently than arithmetic. It does distinguish it. But basically, an arithmetic sequence is one where we add or subtract the same number each time to get the next term, what we'll call our common difference. All right. And so we'll go through some examples in this video that'll get us the idea of what an arithmetic sequence is in the very different ways that we can actually talk about arithmetic sequences and their features. So we've got 6 examples today that go by relatively quickly, and 2 of them are in the level 2 area, so the tougher sort of problems here. So arithmetic sequence is one whose difference between successive terms is constant. That's what we call the common difference, denoted by D for difference, so it makes sense. And we'll have a formula for our arithmetic sequence based on our term n and our difference d, and it goes a sub n is equal to a sub 1 plus n minus 1 times d. All right, and if you worked on the lab, all right, you know where that formula comes from. Another way of writing this, sometimes you'll see this, and sometimes it's easier to use this formula. That is that a sub n is equal to a sub 0 plus d times n. One of the ways of thinking about this is an arithmetic sequence is written in a linear formula, all right, and this a sub 0 is the term right before the first term if we were to have it, and it corresponds to our y-intercept. And then the d corresponds to the slope of this line, right? So sometimes it's easier to see it in the second form than it is the first form. Either way, just know one of those 2 formulas and you'll get by with that. So example 1, determine the common difference and find the next 4 terms of the arithmetic sequence, 8, 0, negative 8, negative 16, and so on. So the first step, we want to find the common difference. Well, if we subtract a2 and a1, the second and the first terms, we find we go down by 8, so negative 8 is the difference. a3 minus a2 also gives us the same difference in negative 8, so d is negative 8. So what we do to find the next terms is we add that common difference, the 4th term to get our 5th term. All right, so we subtract 8, in this case, from negative 16 to get the 5th term, which is negative 24. Subtract 8 to get the 6th term, negative 32. The 7th term is negative 40, and the 8th term is negative 48. All right, example 2, find an explicit and recursive formula for the nth term of the arithmetic sequence, negative 7, 1, 9, 17. The first thing to notice is if you subtract successive terms, you notice you are increasing by 8 each time. So our difference is 8. After that, we want to write an explicit formula. So here's our basic idea for writing an explicit formula. We know our first term, a sub 1, is negative 7, so we plug that in. N is what term we want to be on, so we leave that alone. And our d, our difference, is equal to 8. So 2 ways you could write this. You could say a sub n is equal to negative 7 plus n minus 1 times 8. Or if you simplify that, that's a n minus 15. And one of the ways that you would notice this is if we were to subtract 8 instead of add 8 to get the term before the negative 7, we would get negative 15. So that's like our y-intercept there. If we want to write a recursive formula, remember recursive formulas have 2 parts to them. All right, our first term, which is negative 7, so we write a sub 1 is negative 7. And then how to get our next term, a sub n is equal to a sub n minus 1 plus 8. So notice the recursive formula is a whole lot simpler to write, all right, but it doesn't give us as much information as quickly as our explicit formula does. All right, example 3, find the first term of the arithmetic sequence when the 98th term is 190 and the difference is 2. All right, so we could go through and we could work backwards to try and find the first term, and it would take us forever if we just keep on subtracting 2 and 2 and 2. It's kind of the guess and check kind of way of doing this. The easier way is if it's an arithmetic sequence, we can substitute into our formula. A sub n is equal to a sub 1 plus n minus 1 times d. All right, so we know what a sub 98 is, and it's 98, so we plug that in, 98 for n, and our difference we already know is 2. So we know that a sub 98 equals a sub 1 plus 98 minus 1 times 2. If we work that out, a sub 98 we know is 190, a sub 1 is what we want to find, and 194 is this product right here, so a sub 1 has to be equal to negative 4 when we solve. All right, another thing that we'll be studying is the sum of a finite arithmetic series. All right, we'll talk a little bit about this in class, but basically the sum of the series, all right, is n over 2 times a sub 1 plus a sub n. In other words, the average of the first and last terms multiplied by the number of terms, if you work that out. All right, and this formula would be a very quick way of actually calculating the sum of our series. So for example, we want to find the sum of the series. It's arithmetic. We know it's arithmetic because we have a linear formula right here. All right, the sum from k equals 9 to 16 of 3n minus 1. All right, so we write out some terms. Let's see what we got here. When I plug in 9, that's my lower bound here, at 3 times 9 minus 1. Then I go up to 10, plug that in, 3 times 10 minus 1, all the way up until 16. So I get 3 times 16 minus 1. And when you work this out, this is 26 plus 29, all the way up to 47. And we're going up by 3 each time because that's our slope. So we want to find our number of terms between 9 and 16. All right, we can count 8 terms, so 9 and 16 are included. All right, so we get 8 in total. And then we apply the formula. It's really easy, actually, once you know the formula. Right, so n is equal to 8. We have 8 terms. Our first term is 26. Our last term is 47. We add it up and we get 292. So right now it looks like, oh man, we could have just added those up by hand if we wanted to. But when you have a whole lot of terms you need to add up, it's just really, really fast and is a great tool. An auditorium has 10 seats in the first row and 2 extra seats in successive rows until our 12th row. How many seats are in the auditorium? All right, so here's an example of where this right away is going to reap some benefits for us. So first of all, let's find a formula for this sequence if the first term is 10 and d is equal to 2, because we're going up by 2 seats in each row. So a sub n is equal to a sub 1 plus n minus 1 times d. In other words, a sub 1 is 10 and our d is 2. All right, so we get a sub n is equal to 10 plus n minus 1 times 2, or 2n plus 8 when you simplify that. And if we test it out, if n is equal to 1, we plug that into our new formula and we get 10 seats. We plug in 2 into our formula, we're going to get 12 seats, and then they're going to go up by 2 each time because that's the slope of this function. So now we can just apply that sum formula with n equal to 12. All right, we know what n is, and we know what a sub n is. That's 2n plus 8. All right, so I'm just going to plug in that 2n plus 8 right into my formula right here. And I know a sub 1 is also equal to 10, and I know n is equal to 12. So I'm plugging 12 and 10 into my formula, 12 for 12 for n and 10 for a sub 1. You plug it in right away, you get 252 seats. You don't even have to worry about, oh, I got to do 10 plus 12 plus 14 plus 16. Man, you can still do that, but this is a little bit faster. All right, finally, you're going to learn a little bit about this term called an arithmetic mean. All right, so what an arithmetic mean is, the term in between 2 other terms in an arithmetic sequence is the mean of those 2 terms. All right, it's what's in between them. It's what we call an arithmetic mean. So let's say we want to write an arithmetic sequence with 3 arithmetic means between 1.4 and 9.8. Right? So if we find the common difference between these terms, so we know that if we want 5 terms in our sequence between 1.4 and 9.8, that means 9.8 is going to be our 5th term. So what do I mean by that? Well, our first term is 1.4, and we're going to put 3 other terms in between 1.4 and 9.8. So 1.4 is the first term. We have one mean, that's the second term. A second mean is the third term. A third mean is the 4th term. And then 9.8 is our 5th term. All right, so what we need to do first is find our common difference here. So if our 5th term is 9.8 and our first term is 1.4, and we have 5 minus 1 as our slope, basically, the x part of our slope, we can figure out our common difference is 2.1. In other words, it takes 2.1 4 times to get up to 9.8. And if we add that common difference that we just figured out, we're going to get our missing terms, the 3 means that are in between 1.4 and 9.8. So basically, we use slope in between these 2 points in order to figure out what our common difference was. So A2 is 1.4 plus 2.1, which is 3.5. Add another 2.1 to get 5.6. Add another 2.1 to get 7.7. And if we added another 2.1, we would get 9.8. So we found 3 means, arithmetic means, in between 1.4 and 9.8 to form our sequence with a common difference of 2.1. Notice, by the way, what am I talking about? Why is this means? Well, if we averaged A1, 1.4, and A3, 5.6, then we get 3.5. So in other words, the average of the first and third terms was the second term. The average of the second and fourth terms is the third term. The average of the third and fifth terms is the fourth term, right? So that value is right in between those two terms as our mean. All right, so in summary, an arithmetic sequence is one where consecutive terms have a common difference. We have an explicit formula for the nth term, which is a sub n is equal to a sub 1 plus n minus 1 times d. And we also have a formula for the sum of an arithmetic sequence, which is n over 2 times a sub 1 plus a sub n. Thanks for listening. We'll see you on the